with that idea of being a hobby developer, Mark Barkmin is telling us today everything about OpenPatch. So welcome, Mark.
Yeah. Hi, and welcome to my talk, OpenPatch, an example for building microservices with Flask. I will not tell you much about OpenPatch, but more of the programming features and the underlying architecture. But I will, of course, introduce it. So you can find me at Mike Barkmin at Twitter. I'm a computer science education researcher and a hobby developer or a spare time developer. So to not confuse everybody. You can find the slides at my website, barkmin.eu. Now I will talk a little bit about the agenda which I will follow. So I will introduce to you what is OpenPatch, the platform which I have built. I will talk about the architecture of OpenPatch, and then I will focus on 4 core components which I have abstracted out of OpenPatch. So this might help you in building microservices with Flask. I will talk about authentication, communication, versioning, and deployment. Hopefully everything in 20 minutes. So let's start with OpenPatch. So OpenPatch is a platform for creating exercises and tests which are automatically evaluated. And yeah, this can be used to, for example, test the skills of programmers. So it's a social website. So the task, which can be interactive, and the test, which can be adaptive, can be shared by educators and researchers, can be commented on, and can also be remixed, so adapted for your own needs. And the process of finding a solution for a given exercise can also be recorded, so you get a better insights on what is going on when solving an exercise. This is everything I have to say about OpenPatch. You can find the GitLab repository and so on. At the moment, it's non-public beta, so you cannot jump on the website and register yourself and use the platform. But you can find all the source code, everything is available. It's open source, so you can deploy it on your own local machine. So let's see. Then the next point is that I want to talk about the architecture of OpenPatch. This is more interesting to, or more of general interesting. So it's microservice architecture. The main technologies which I have used are MariaDB as a database, Python Flask for most backend services. Some also are implemented in Node and Express. And for the front end, I use JavaScript, React, and Next.js. So the talk earlier is might give you some idea how I've implemented it, but I will not go into the details of how I connected the front end with the backend. I will mainly talk about the backend. And some of the services are not only communicating over HTTP, but also over AMQP, and therefore there's also a RabbitMQ message broker implemented in the architecture. And every microservice is containered. So I use Docker for this. And yeah, on the right-hand side, you see the architecture, which might not be very interesting. So let's get started about the 4 main topics. How does it work? So let's talk a little bit about authentication. I guess we've seen a talk about Auth, for example, or about JWT tokens yesterday. I use JWT tokens, but in a microservice architecture, you not only have one service which you need to call to authenticate a user. So there were 3 main models I could have used. For example, if a client wants to authenticate him and wants to call service 1, all request needs to go to an Auth gateway. So this Auth gateway handles the validation of the JWT token and then proxies the request forwards to another service. This could be one possible example. Another possible solution could be, I have an Auth service. The client logs into the Auth service, gets an JWT token, uses this JWT token, and sends a direct request to service 1. And service 1 is capable of verifying that this JWT token is valid. So service 1 needs to implement the validation, and service 2. And the thing I use for OpenPatch is you have the Auth service, you gets the JWT token by requesting the auth service. Then you're sending the JWT token to the service, and the service then requests the auth service to verify the token. It may seem a little bit indirect, but therefore the validation of the JWT token does not need to happen in service 1 and service 2, but only in the auth service. And now I will tell you how the auth service is built. So the auth service might look like your regular service, not microservice service. I use JWT extended first, so the Flask library. It has a login route, and register route, refresh route, verify route, and a logout route. So this is all for handling the JWT tokens, and some other routes are for resetting the password, resetting the email, sending a conform email, and new policies like GWE policies that checks for that. So you can find the whole code under this URL if you click on it when you see the slides. But I will show you a little bit how this indirect authentication works. So I've created a core package for OpenPatch, and this core package implements JWT required decorator. You might know the JWT required decorator from Flask JWT extended, but this decorator does work a little bit different. As I've shown you earlier, it does not verify the token in itself, but what it does, it gets the URL to the authentication service, proxies the header, and then calls the verify route for the endpoint from the authentication service. And if it's returning a 200, then I know the JWT token is valid, and I can continue to process whatever I want to process in this endpoint. So for example, I import JWT required from the core package, and then I can just decorate my route, and that's it. So automatically JWT tokens will get verified by the authentication service. And you can find any information about that and the implementation under this link. So be sure to get the slides afterwards. So now I will talk about communication. How is communication done in our system, in my system? And you have seen one type of communication already is the communication over HTTP. And therefore I use the request library. And as you have seen earlier, I use it for the authentication process. So if, for example, service 2 has a direct connection to service 3, then they will talk to each other over HTTP. But there are also a connection about over AMQP, so an asynchronous communication. And therefore I use picker. So let's say service 1 is indirectly connected to service 2 over the messages broker. And this is used for sending out emails, for notifying for new activities, and so on. And I will go a little bit into detail how these both communication forms work. So the HTTP communication is what you have already seen. So just pass in the authorization header, call any URL output from any service you want, and act upon the response, and then you return your results. So this is communication over HTTP and the microservice architecture. Our communication over AMQP is a little bit more advanced, I would say. So what you need here, I don't know if you're familiar with RabbitMQ and AMQP. If you're not, you might stop, or you might watch this RabbitMQ in 5 minutes afterwards. So, but I will glance over it. So I've created a module in this OpenPatch core library, and this just works like a regular Flask extension, and you can decorate a method with this object and the queue method, for example. So this here defines the queue, and the queue is basically something which listens for new messages. And every time a new message is posted to this queue, this method will be called, and you can do something about it. For example, sending out an email. And how you send out something to this queue. It's also very easy. You would just use this RabbitMQ object and would say, I want to publish something, here in this case a comment, to an exchange, for example, with a routing key. There are many ways how you can send out messages. So you can also send out a message by its headers or by a fan out. So these are concepts from RabbitMQ, but they are all supported in this model. So you can also find this model on the GitLab repository. So that's nice. That was communication in my microservice architecture. So as I have explained earlier, everything will be a little bit faster, but I hope you get the ideas and then you can look into the different models and see what's really going on. So now I will talk about versioning, and versioning is very important. When you have a microservice architecture and you have the service 1 and the service 2, and they are connected to each other, you want to be able to improve on service 1, even with breaking changes, but don't influence the workings of service 2, even though they are connected. So if you introduce breaking changes, you need to be sure to keep backwards compatibility. So maybe they are not even considered breaking changes, but I will go into this a little bit further. So every service in this microservice architecture is versioned by a specific theme. And this schema is semantic versioning version 2.0.0, as you can see. So every version is, for example, 1.0.0, where the 1 represents the major release, the first O a minor release, and the second O a patch release. So major releases represent some breaking changes in the system, which break backwards compatibility. Minor changes are representing new features, and patches representing bug fixes, for example. So everything is, this versioning is not done by myself, but by a GitLab pipeline, which does it for me. And it does it for me by analyzing my Git commit messages. So if a commit message, for example, has a feed keyword in the subject, then this GitLab pipeline knows that it should increase the minor release. And when in the footer, for example, is the keyword breaking change, it knows it should release a new major release. So for example, let's say our service has version 1.0.0, and we commit something with this commit message, feature add avatar to member. Then the GitLab pipeline will say, okay, the next version is 1.1.0. It will generate a change log depending on the Git commit messages. It will generate new Docker images depending on the Git commit message, and so on. So everything is automated. But this is just versioning. Let's see how it would work in a given example service. So most of the services are structured like this, which I'll show you here. So we have an API model, and under this, and also modules models where the SQL Alchemy models live. And under the API model, they are models for the versioning, for example, version v1 or version v2. And each version has some endpoints defined and has some marshmallow schemas, which are used for validation and so on, and some custom error codes to be more specific than, for example, say for 2020 or something like that, 22. This was 22. So let's see how this example service works. So this example service has two routes. One get route, which just uses the marshmallow schema and dumps everything which is in the database for this model. And a post route, which just gets a JSON object, loads this JSON object, creates a model instance, and then it saves this model instance to the database. These are the two endpoints. The database model for this service is at the moment just simple one model sample. It has an ID and sample name. And there's also a marshmallow schema, which at the moment mirrors what the database model is. So it has also a name and a sample name. So let's say we want to introduce a new feature for version 2.0.0. we want to, for example, add a value to a sample. This would be considered a non-breaking change. And we would like to return a JSON object instead of an array, and want to rename sample name to name. So this might look the external, in such a way the external API would look like. So let's do that. Of course, we would say, okay, let's change the database model first, but this breaks, of course, older versions because older versions rely on sample name. So we have two to-dos: fix our older versions, and second, implement a new version. So let's fix our older version. It's very easy. Because we are using marshmallow schemas, we can only change the marshmallow schema and say sample name should not only be an auto field, but should look for the column name, because we have renamed the column from sample name to name. And in my case, also some test breaks, because I check if the value is really stored in the database, and therefore I have also to work on my tests. So let's implement version 2. So at first we return an object instead of an array. This root does not change because we will modify the marshmallow schema. And the marshmallow schema for version 2 will look like this. As like version 1, before we introduce the change, it will just mirror the model at the moment. So no validation or whatever. So the last thing we have to do is to register. So I'm using blueprints for that. So we are registering this v.2 module at the prefix v.2. So now we have introduced a new version to our microservice, but there remain two own questions. One is, should you version everything at once? And the other one is, or should endpoints which produce breaking changes only be versioned? So for the first question, so let's assume that version 2 will have all endpoints version 1 has. So let's say version 1 had a login and register, so version 2 will also have login and register. But let's say only those endpoints which produce breaking changes will be re-implemented. So version 2 will only have changed endpoints. So version 1 will be login, register, and version 2 will be register. So of course you keep the code which is duplicated low, but this might confuse users when version 1 does not have, version 2 does not have a login endpoint, for example. So I would at the moment say, just copy over the v1 model and then modify it accordingly to your plans. So last thing, deployment. Everything is infrastructure as code. So that no human interaction has to, no SSHing or some kind of this by myself has to be done in place. So everything is in Docker container. I use Terraform to provision servers, and I use Ansible to deploy a Docker Swarm cluster and to create the Docker containers in this Docker Swarm clusters. Even this infrastructure is open source. So if you're interested how this works, you can go into this GitLab repository and you see how this works. And as I said earlier, everything is automated. So when a new version is recognized by my system, so by a GitLab pipeline, the pipeline will automatically update all configurations and then try to deploy it. And it will halt at some point, so I can manually check if everything is all right, and then I can hit run, and the new version will be deployed. So this was quite fast. I wanted to go over every aspect which I use in the authentication, communication, versioning, and deployment process. I hope you get something out of it. And if you have some question about it, feel free to ask. Thank you.
Hi, Mike. Thanks. This is Surja. I am the co-host of this event. And hi. So great presentation. Do we have any questions for Mike?
Discord, I'm checking.
Sorry, Abdur, we didn't get you.
On the Discord, there are no questions I see.
Okay.
Yes.
People are typing though, so we might get one or two. So just hang in there for a second.
Yeah, no problem.
Well, they're saying thank you for the talk. Very good talk. We agree. So thank you.
Nice. Yeah, I mean, I glanced over some of the things, so maybe these 4 points could all have been one talk on its own. So I could go a little bit into more detail, but let's see. There's some questions coming.
Maybe why you choose Flask?
Why I choose Flask? It was very easy to build these microservices with Flask. And after hearing the talk yesterday about Flask REST, I not regret, but I try to think about for myself if I should move from plain Flask, which I am at the moment used to create these endpoint for my microservice, to Flask REST, because it was a very nice talk and it's a very nice project.
Yes, I think you have also Flask Reborn, which is a bit like Flask REST. Okay, and we have a question. Someone asking, what is the graph editor you showed at the beginning?
Okay, the graph editor. So this is part of the React front end. So but it's not only a React component. Of course, I created a React component first, but the JavaScript project is called This Network. So WIS and -network. And this is used for creating the graph structure at the beginning, which is also interactive. So you can create nodes and new edges on the fly. Or do you mean the graph structure of the microservice?
I think that answers the question. And it's his URL for, I think the talk URL will be your slides. Maybe someone asking for URL, I think, for slides.
Yeah,
and
I can.
Okay, so
I can
maybe
put
on
them
the. Okay.
So someone is asking for posting the URL in the Discord.
No problem. I will do that.
Yep. It was a really cool presentation. So just out of, not related to this particular presentation, as a developer yourself, what do you think authentication versus communication versus deployment, in which part you think more customization is required from our end? Because, some things has been built for authentication, right? We have architectures for the services, we have straightforward frameworks. But for me personally, I think for every single project, deployment is the part where things go very wrong. So we need to do a lot of customization at that point. So what do you feel about, the development process as a whole? Where is the most customization and pain exist?
Now the main
Actually, not pain. It's actually fun to customize.
Yeah, it's fun to solve hard problems, I guess, or maybe not hard problems, but problems. So yeah, so the most fun is to see the green dots in my GitLab pipeline. So I have introduced unit tests and everything. So and this is also the hardest part, because I'm a single developer. I've developed the system on my own, so I want to use automation. Automation for my benefit. So I guess the hardest part was to get as most automation in this project as possible. So that the new versions are released from my commit messages, that the infrastructure code repository picks these new versions up, runs the pipeline, the CI, so the whole CI/CD process.
Pipelining, yeah. Okay.
pipeline, yeah, workflow.
Such an honest developer, because I wouldn't do any unit testing or automation for my personal project. Yep. Nice, nice.
So Flask was the easiest part, let's say it in this way.
Yeah, we can see that.